putting this together. It's fair to say, I think, is this correct? This is really certainly the first NBER event, and certainly one of the first few events, I think, that really has emerged around the notion of really studying artificial intelligence through the lens of economics in a sort of systematic way. And I really just want to, thank the organizers for their extremely high ambition, bringing all of us together today, as well for those of you who are paper authors for the unusual approach that they took to this conference, which was to assign topics with a relatively short deadline that you will produce. You keep on sending emails as if that was definitely going to happen. So, okay. So, and this is joined with Iain and Rebecca, and certainly very preliminary in nature, but let me just get started. So, the first thing that I think is really important is to recognize that, as we're going to hear about in the second paper, is going to be reflected in many themes. A lot of people are going to say this deep learning is something of a general purpose technology, and that's an incredibly important idea. And I think it's important from the history of innovation, is it really that you can't hear it because I hate using
No, but it's also so that it's being recorded for graduate
Is
students.
there possible to get a lapel?
Not fast enough.
Okay,
Sorry.
because I'm really bad with these, but okay, I will try to use them as well as possible. So it's fair to say that that when you really think about what general purpose technologies look like, and there are not very many of them. We often think, oh, this is, many times people say, oh, this is a general purpose technology in the sense of it has a few applications. When you really talk about the kinds of things that Tim and Manuel were thinking about, that Paul David, that Nate Rosenberg, that Zvi Grilikus thought about when they were trying to really think about that in technological terms, you really have to think about the profound influence and very often unanticipated influence that the development of general purpose inventions for the method of invention have on the economy. And specifically, I'm going to take 2 seconds on this because Iain and Rebecca want me to get to the economics. It's just, if you think of, for example, the development of lens making in the 14th and 15th century, there's no doubt that the main application that people thought about, and had many applications, was basically to give people glasses. And glasses were a first-order effect on people's lives. They had lots of good benefits. There were some, obviously people who were more well-sighted were a little bit harmed in the labor market because now there were these competitors who had previously been consigned to other jobs. But interestingly, right, in that kind of ferment around in Amsterdam at that time, what then happened was that people realized you could make a microscope. And that was unanticipated. And very shortly after that, they realized you could make a telescope. And what the microscope and the telescope and the development of lenses did was they literally allowed you to resolve phenomena that had previously eluded any human attention. And that was one of the greatest transformations in science. It basically created science. When you think about what was Newton whining about when he was standing on the shoulders of giants, quote, it was all in his discussion with Robert Hooke about who could do the optics better. And it really was the development of lenses as a tool that opened up these unanticipated trajectories. With that said, let me just we already heard this mentioned already, is just to kind of highlight that it's useful to think about that right now what people are calling artificial intelligence covers lots of things. And some of those things look like Atomwise, which are using quote-unquote deep learning, which we'll talk about in a second, to make predictions about phenomena, basically drug candidates, that had previously required systematic work and basically almost a kind of routinized problem solving largely by humans. At the same time, this over here, and I bet I'm pretty sure David Otter, when he gets here, he'll have this up. Eric, I'm sure, will have this up, so on and so forth. That's Baxter, the robot from Rod Brooks's Rethink Robotics. Let me be clear, Baxter is an incredibly cool thing. I have played with Baxter. He is fantastic. But Baxter is not, while you might consider it artificial intelligence, Baxter is robotics. And that turns out to be a big difference, which I'll talk about in just a second. So what you have going around is this kind of like swirling group of technologies, some of which have this feature of prediction, and some of which are the ability to use various forms of mechanical systems and information technology to reduce to practice a variety of basically trained techniques. Okay? So, how are we going to do this? I'm just going to talk very briefly about that distinction a little bit more, and then I'm going to talk about the economics of both general purpose technologies and inventions for the method of invention. Then I'm going to talk about a little what we've done in trying to uncover that in the context of traditional innovation metrics, papers, and patents to try to understand what's actually going on in kind of large-scale population data set. And then what we're going to try to do is kind of thinking about that in terms of some implications. And let me be clear, this is both quite preliminary and also incomplete in key respects. So the first thing I want to just say is that just to kind of highlight that there really is a gap here between basically, just as we would have in economics or any field, there are fields within that field called artificial intelligence, of which at least 3 are the area of symbolic systems. Many of us who did like computer science courses in undergrad, that's a lot of what you would get. That's like Herb Simon, so on and so forth. And that really, the goal was to really make intelligent machines that can reason. That field, as best as we can tell, no one's made any progress on. Okay? People work in it, and that's very good, and there might even be people in this, and I don't want to be, right? But basically, that field has not made a lot of progress, or is not the key area of progress. The second, which has been an area that has been much more applied in nature, is the field of robotics. And robotics, the key insight of Rod Brooks, as well as many other people in that field, was not to make machines smart, but was to make them incredibly dumb, but do really simple things, but do them really well. And so when you think about your Roomba, when you think about Baxter, and the key idea was elephants don't play chess. The idea is you kind of purpose solve this technology, give it sensors, give it a program and what to do to the sensor, and just sit there. And then there was this other area of which Jeff Hinton has been a leader for a long time, as well as others, that were around neural networks and learning. And the key insight there that I think it's fair to say was mostly overlooked by much of the broader field was the idea that all you would do is focus on prediction of unstructured problems that often are not monocausal. Okay? What we're going to claim is that there seemed to be a big thing that happened here. It was already mentioned. This, in 2006 and onwards, there was a series of papers that came from here as well as other places, and then the 2009 ImageNet competition absolutely transformed people's view on the performance probability of multi-layered neural networks. It was it's an unanticipated right the day before it happened, and then big technological advance that we're only starting to absorb at this conference. And so how might this purported shift of the science of artificial intelligence influence the rate and direction of innovation? So let me just make sure I kind of highlight 2 things. I'm sure some of this will come up in the next talk. First is the point that once you say, in a way that robotics, you could see how to apply it to many things, but each of those things would be a relatively narrow thing. That's, in fact, the whole trick. Okay? Multi-layered neural networks, i.e. deep learning, have the feature that could be applied across a wide variety of sectors of the economy, many of which only have limited absorptive capacity at this point to really think about what the implications are that we can now predict a disparate array of phenomena, particularly of rare events. Okay? Why do I want to talk about that? Because the economics of GPTs, we often use that as a kind of shorthand to say things are interesting, but I think that the reason, right, that Tim and Manuel wrote that paper was to actually make an economics point, which is to make the key claim that when you have a true GPT, you face a first-order problem of how do you provide incentives to each downstream sector, since there's complementarities between the upstream and downstream. And moreover, the coordination of that between upstream and downstream has the additional benefit of horizontal spillovers across sectors. So in other words, in a GPT is really a systems innovation in which many different downstream applications are all feeding, because their innovation capabilities and their innovative investment is raising the marginal returns to the GPT itself. You end up in this kind of self-reinforcing loop if you can, but that's not guaranteed. It depends on institutions, it depends on competition, it depends on intellectual property, so on and so forth. The second lens that we sort of spent a little bit of time on, which in some sense is related to GPTs, but in some sense GPTs has mostly been about technology and R&D, goes back to, at least Alfred North Whitehead, who, claimed the greatest invention of the 19th century was the invention of the method to invent, and was picked up by Zvigrilikis in his famous studies of hybrid corn. And what V's point was in hybrid corn, and what we call IMIs here, is really that you cannot, that at key moments that aren't true for every even GPT, what you end up is with something where you end up with effectively a new playbook for how to do technical change, right? So the usual thinking you have about what even innovation would look like is going to change, because now there's like a new playbook here where what you can do is say, I'm going to figure out things that I have large data sets on to predict stuff that I used to think I couldn't even look at. That was kind of the ether. And then I can focus myself on what human needs and wants, or what pieces of cost, or what operational efficiencies I can get through understanding those predictions. That is just a different algorithm for how we would think about what scientific output looks like, what in fact innovation is. Specifically, what we would claim, and I think this took us a little while to get to, is that very often the conversation here has sort of confused a lot of different things that are going to have very different, even order of magnitude, economic consequences. So on the one hand, and Daron is not yet here, has a very nice paper on the impact of industrial robots, and then tries to analogize that to say, well, if you get more artificial intelligence, that's like industrial robots, here's what's going to happen, labor displacement. Well, industrial robots are not at all this technology. First order. Similarly, there are very narrow things, MRI algorithms, that have absolutely transformed fields, but in relatively narrow ways. There are more general versions of robotics, think of Baxter, pick-and-place robots, but that's, once again, not really changing how we invent things. Deep learning is at least a candidate for something that is simultaneously general and simultaneously a reorientation of how you would, the innovation production function itself. It's it's essentially changing the idea's production function. Okay? So, where we ended up here, in terms of kind of our conceptual understanding, is saying relative to other areas of artificial intelligence, probably relative to innovation in general today, this sounds like the best candidate for a general purpose invention for the method of invention. Okay? It's me and Iain and Rebecca. Yep, I'm getting there, right? It's right, so we're like, okay, let's go see if there's any evidence for that. So what we did is we collected a data set of all public, yep, see, I have 3 more minutes than you think. Okay, that's the precise algorithm that was the predictor. Okay, there you go. We got all publications in basically computer science that have any keywords that even, we looked at the entire corpus of Web of Science and the entire patent database to look at any article or any patent that has anything to do with artificial intelligence in any form. We were then able to develop a classifier by hand. This isn't some fancy thing that we did. We could do that, but this is brute force, to divide those into these 3 subfields: simple processing, robotics, and learning. And then we basically have just looked at very descriptive statistics to kind of highlight a little bit what's going on. The first thing to notice here is that basically as of 1990, even though some of the giants of the field had already passed, this was a tiny, tiny field that has, in every sense, in all 3 areas, has dramatically grown. But that learning has grown a lot more than everything else. The second is to recognize, and I just think, a little bit, and we were going to do some like fancy Canada graphs here, but we kind of ran out of time, okay? But it's fair to say this is an area that many people identified as promising, and the US in particular, and even at elite US universities, has had relatively low investment relative to the rest of the world, okay? Key is we then divide all the publications into things in computer science and things in applications, things that are outside of computer science. And what we find is this sharp break in 2009 with a rapid acceleration in application sector research exclusively associated with learning relative to other things. So there really is this just absolute break in the data. Moreover, when you kind of look at, and once again, this is sort of too hard to read right now, but when you actually look at where things are happening, in some sense, like one thing, I'm not going to go over this chart in any detail, except to say some areas such as the radiology, we're going to put the radiologist out of business example, that's been a business of machine vision for 25 years. Like that's actually a sect, right? The key thing here is that there's all these new areas, such as economics, looking at you, Susan, okay, right, that all of a sudden are using these techniques in ways that previously had basically not been in these fields. So we see this introduction of basically a new tool absorbing into a wide variety of new fields. So what are the implications? First, and I have to admit, like I've been in sort of, I'm just coming off sabbatical, and basically I kind of feel like, maybe I'm, too kind of, in too much of a mode around this. But let me be clear. As somebody who studies innovation, I've had the opportunity to talk to scientists across a wide variety of disciplines for various projects, from biology to physics to computer science to various other areas. And it's fair to say that I've never seen the shift here that when you think about what science is or when engineering is, engineering problem solving, basically most of the time what we try to do in an engineering class or a science class is reduced to the smallest number of parts, but no fewer, so you have a small number of causal factors that run a system. What this is about is saying, I don't care about quote-unquote monocausal reasoning. What I'm interested is prediction. And what that allows me to do is deal with extremely complex phenomena that might occur only occasionally, but when a bunch of things happen that precede it, I get a rare event. That's both a problem for an auction theorist, as well as for drug discovery, as well as for nuclear magnetic resonance. Second, what's that going to do when you make that shift? It turns out that there are big areas of science that do try to do this prediction job. And guess what? There's going to be probably a shift away from high marginal cost labor towards AI capital, right? So the same thing that we see, the same thing that we see in the real, in the real economy is also going to happen in the innovation economy. Third, those jobs of those very routinized things that you would see in a drug company or even in semiconductor process, material science, many of those areas, all of a sudden you have low barriers to entry. Why do you need a PhD in tuning the machine and doing these very complex repetitive tasks when basically you can access a data set? And then finally, it's the possibility that, and personally I view this as right, is that you might really discover big things that we didn't even know about. The microscope, before the microscope, people didn't even think, they just didn't even ask the question, what is a cell? They didn't even know what that would be, right? Second, innovation policy. First order economics here. There is a first order question about what is the appropriate set of institutions that we need to ensure high levels of application innovation that flows both up to the upstream and also creates some standards so that you can kind of take advantage of the horizontal spillovers. Second, there's very likely to be a very significant gap, building on that first point, between the private and the total social returns to data sharing and transparency. Let's be clear, once you get unstructured data sets that people are keeping private, I hesitate to worry about the replicability crisis that's pervading many, many sciences today. And then finally, that means that proactive policies encouraging transparency and data sharing are likely to yield higher innovation and productivity. And this is my next to last slide, right? I'm almost on time. Last point, and I think this is something that's going to be reflected in several talks today, is effectively, if you really buy this kind of argument, what it tells you is at least that you don't need network effects in the market. There's increasing returns to data. Once you have increasing returns to data, that means right now, if I was an entrepreneur or I was an established firm, I would be in the business of racing to get that advantage. Why am I racing to get that advantage? So I can lock it in. If I lock it in, what's the consequence of that? I'm not going to share it with others. And once again, I mean, Susan might disagree on this, but it's fair to say that a little bit of a bit of a head start there for Google really did have some lasting impact in terms of just the depth of search and the ability to do that. And once again, the interesting thing about Bing was it wasn't a few people in a garage. It was a kind of fairly well-funded effort with a few really good people, right? I love Bing, by the way. Okay. Not anti-Bing, okay? A key insight from that is it's sort of like the worst of all worlds from an I/O perspective. You get duplication and overinvestment today, and then anti-competitive conduct tomorrow. Now, let me be clear, there's lots of things that unlock that. There's a very general purpose technology with unanticipated benefit, unanticipated openings. Maybe there's just lots of data sets that are going to be running around, and maybe it lowers the barriers to entry. But the key is to understand that it's very likely going to be the case that the access to these pools of data that themselves lead to predictive analytics at a much, much higher level of performance than had previously been attainable is likely to have a significant shift in the ability to transition between incumbent and entrant. And that raises a bunch of policy questions, one which I think Carl and Hal might be talking about later today. Is data, or these big data, an essential facility? I thought that was a really good point you guys make. Second point, which I guess I wake up to now every day, right? Who should own this data? Right? The data, by and large, that we're talking about results from human behavior or human action on physical systems. Yet the people who are owning the data have nothing to do with that. And fundamentally, right, as Catherine and Christian and Susan's very nice paper, people are willing to give their privacy for basically, a piece of pizza, and we maybe might think that there might be something more systematic to be done. So, where are we? Maybe we can talk about this as we go forward. I think if we really believe this is a GPT, we should be clear about its nature. And one version of the way in which it's a GPT more than some others, in a kind of well-defined sense, is that it might also be an invention in the method of invention. That has, I think, very deep implications, if true, about what the scientific research and innovation enterprise will look like in 20 years and going forward. And interestingly, if you think about Daron's paper with Pasquale, that's about basically, well, we have to find these new tasks for people, right? Many of you know that paper. Interestingly, the mechanism there is just a demand mechanism. But this is saying there's actually, the technology itself actually maybe can help us actually identify things to, I guess, keep us busy while the drudgery of repetitive tasks that have taken up much of the real economy get automated by AI capital. Thank you so very much.
There it is. It's a pleasure to be here to talk about something I know nothing about, artificial intelligence. But it's been fun to think about, and this is a very interesting paper that brings up a lot of interesting ideas and also organize some data that I hadn't thought about before. So, so questions that come up in this paper. First, what will this new technology mean for innovation? And sort of second, and the one that I'm probably going to maybe focus more of what I was thinking on, what does this imply for policy? And I'm going to think especially about intellectual property policy, because that's actually something that I've studied before, and I might as well talk about something that I've thought of before. So my first question when I was reading the paper was sort of, do we need a new model for thinking about this new thing as compared to other new things we've studied in the past? And sort of my first pass is kind of, not really. I mean, we have models of general purpose technology. I'm kind of a, preferences technology equilibrium kind of guy. This is a change in technology. We can handle that. But I think the thing we want to focus on is specifically, what does this technology do? And I'm going to stress, is this technology more about innovation or more about copying? Because that's going to be kind of fundamental to things like policy questions. And then I want to think of course, in the paper they talk a lot about equilibrium effects. That is, what effects will this have on factor prices for things like the price of data? If you want to think about like the sort of the value of having data, it's like its price. I want to stress that the idea of non-human intelligence making innovations is not a new idea. This is the classic idea. Here's some non-human intelligence making the works of Shakespeare. Okay? So people have thought about this idea for a long time. It's just that this technology wasn't worth operating unless you were like Mr. Burns. So the idea is that now this technology is worth operating because we've replaced those guys with something that looks roughly like this. And it's a little hard to see exactly what those inputs are because Google doesn't let us inside and wander around very often and see exactly what the inputs are. But we got a rough idea of what's going on inside that building. There's some computers, and there's some data, and there's some algorithms running that some smart people have invented. That's a Google data center. So what are the implications of this new technology for innovation? Well, a more productive technology for something will usually increase the amount of it, and mostly this is good. Of course, there's always economists telling you about the bad side effects. A bad side effect would be duplication that Scott was talking about. So the idea here is that if everyone gets a really productive hammer, not only does everything look like a nail, but people go running around looking for the nails. Because after all, even if you have private ownership of the hammer, which is like the solution technique, problems themselves are essentially unowned. And therefore, there's like a tragedy of the commons in problems to solve. So anytime there's a new technology, like a new type of hammer, we may be concerned that people are going to run around chasing after the same nail and wasting their time on specific nails that the hammer's really good at hammering. And a paper that I saw recently that I think is related to this, even though of course they say nothing about artificial intelligence, is this paper by Hobenine and Squintani on the problems of unowned problems. So what about implications for factor prices? That's another thing they talk about. Well, I mean, there's some of them are sort of, I don't want to say obvious, but it's like economics we all know. We know from like capital skill complementarity. If you can write a really good algorithm that can use this new technology, your value is going to go up. But I think maybe the more interesting input here is the data input. I'm going to talk about why I think that's sort of interesting in a couple minutes. But in particular, we have this idea that data is going to become, in a certain sense, scarce. It's going to be an input that everyone's going to chase around to have. And what I want us to keep in the back of our mind about data that's weird about it compared to most inputs, but similar to other inputs we've thought of in the innovation literature, is that you can make copies of it almost for free. That's very special compared to smart people. You cannot make copies of smart people almost for free. That's going to be an important thing to think about. So I want to stress that while the AI is likely to make innovation cheaper, it also may make copying cheaper. I kind of didn't realize this room was going to be that big, so you may not know what I just took a picture of there. So instead of a picture of the Google's call center, this is a picture of Google News. Now, the actual Google News site, I'm not sure to what extent that uses machine learning yet. Supposedly, the thing on your phone that gives you a news feed has some machine learning running in the background. I keep looking over at Hal to see if he's going to tell me. No, none of that. But anyway, so this is an idea of something that's running something like artificial intelligence to produce a new thing, an innovation, that some people view not as much of an innovation, but mostly as a copy of the underlying innovations, which are these news articles that it links to. And therefore, this has been somewhat controversial. In Europe, Google faced particular regulatory oversight related to Google News. And the basic question is this an innovation or is this a copy of someone else's innovation? And so it's sort of an open question when you see this, whether or not this new technology is going to be more about producing innovations or about producing copies. And that's pretty important when you think about sort of incentives to innovate. So let's think about policy implications for a second. To the extent that this new technology is going to make innovation more productive, then intellectual property protection could probably be less strict. After all, if there's less cost of innovating, we don't need to give people as much monopoly to convince them to do it. Of course, there's some caveats there. On the other hand, to the extent that this new technology might make copying cheaper, like if you think of this as copying and not innovating, and I'm going to argue in a second it's kind of somewhere in between, then maybe we're going to need to make intellectual property protection more strict. And that's the nature of the European regulatory oversight of this, is that maybe Google should have to compensate the underlying innovations in a way that nobody would ask you to do if you were just a human being saying, hey, I read on The Guardian this news story. Nobody thinks you should have to pay The Guardian. But the European regulator at least thinks maybe Google should have to pay Guardian if they do that with this new technology. So this is going to be in some sense a sort of fundamental question, this tension between are we producing more innovations or are we using this technology to produce more copies? And I want to flag something that when I was thinking about this issue struck me as kind of fundamental about artificial intelligence. In the patent context, the way we decide whether something's an innovation or a copy is by something called the non-obviousness standard. I'm not exactly sure how we're going to apply a non-obviousness standard to something that has been produced by a machine. Because the usual way we handle something like the non-obviousness standard is to say, is it obvious to a person? But these innovations may not have been produced exactly by a person. They're produced by some combination of a person and a machine. And so deciding what's a new thing and what's a copy is going to be fundamental if we want to think about how this technology is going to impact innovation. And the second thing I want to talk about is about data. So, yep, perfect. So, you know, when something becomes cheaper, people are going to want to monopolize complementary inputs. In fact, sometimes when you teach MBAs, you don't say this out loud, but you practically teach them to monopolize the complementary inputs. And so if this technology, that box that Google has, is going to get cheaper, you're going to want to monopolize the complementary inputs, which in this case I'm thinking of as data. But I want to stress that in some sense, data, as I said before, is not like most inputs. We can make copies of it. But we know from the innovation literature, you don't necessarily want to let everyone make a copy because that has incentive effects. We don't let everybody make a copy of a blueprint that someone invents just because we can. And so in the paper, they talk about data transparency and who should have access to data. And I think there's going to be a fundamental tension here because this input has a very special feature. Copies can be made, but those copies are going to have an effect on incentives to work with the data in the first place. Okay, so that's everything I have to say, and I think I'm out of time. I just want to stress, I think that this could be a new technology, is a new technology for innovating, may also be a new technology for copying, and so we're going to have to make some decisions about property rights and what should be allowed to be owned and what we should make copies of.
Okay, thanks, Matt. So we'll take questions now for who else is.
Okay, so this is a very stimulating paper. Essentially, you floated a few concepts, and I think we need to clarify them. So let me mention what I wrote down to myself as concepts. One is GPT, all right. The second is a method of inventing a Lagrange case. We understand that, but that's very specific to a specific field, or even narrower than that. Then you hinted at a kind of something like a research tool or a generalized research tool a la Rosenberg, okay? and then this general purpose method of inventing. Now, these are 4 different notions, and the question is, do you refer to AI as all of them, as one of them, and particularly the difference between a research tool and a method of inventing is key in terms of policy. And could it be that the same thing evolves from being one into the other? For example, the computer at the beginning was more like a research tool that evolved into something like GPT.
Susan?
Yeah, so I'll cheat and take 2 minutes that I won't have to say during my talk later to pick up on that. So I think actually, to me, one of the things that was really interesting when I first started working with the search engine in the mid and late 2000s was the kind of general, I think there's a set of general purpose technologies that tends to go together with the adoption of AI, and the A/B testing platform tends to go together with AI and machine learning because you have these algorithms that you're incrementally improving. And when you've set them up with like a short-term objective, a clear objective, like you're going to use X's to predict Y, or you're going to get users to click, or other types of things. And so they tend to be amenable also to a lot of incremental improvement testing and innovation. In addition, because a lot of them are a little bit black boxy, it's even more important to see how they work in practice. The engineers may not really know how their improvements are going to work. And so one thing I don't think has been fully fleshed out and appreciated, except by the people who've gotten in and lived it, is how much the A/B testing platform as an institution has changed the practice of innovation and really changed the way firms operate, the way that they become more data-driven, and so on. And there's sort of an interplay between these two technologies that I think, down the line, like, everybody's going to know about randomized controlled experiments, and actually they're much more sophisticated than any economist is about the science of experimentation and so on.
Shane?
Enjoyed this very much. If we're going to talk about changes in the cost of innovating in a specific area, sort of follows quite quickly to ask the question, where is there underinvestment in public goods related to that innovation? And I heard you guys to say, though perhaps not directly, that you're forecasting tension over underinvestment in data because it's clearly complementary to the invention we're going to see. And so I immediately came to mind things like the human genome and maps of the world and big complex data sets that are complementary to machine learning. But then it begs to me, it sort of motivates a further question, which is what other complements do you anticipate might require further investment and might be suffering from underinvestment in particular, if this is the framework we use to think through policy? And so things that come to mind, for example, are standards over computer fields that turn out to be essential for communication, or in these applications, or potentially technologies that coordinate between multiple actors or participants who are each using their own algorithm. I think in transportation that's already started to show up. And so some thoughts on that would seem valuable here.
Okay, thanks, Shane. Hal?
Well, I have several things to comment on in the presentation.
Sorry, Hal, do you mind just turning your mic on?
Sorry, yeah, thanks.
There we go. One of them is this increasing returns to data, which I'm hearing a lot of lately. There are no examples of that. First, my rather strong claim. If you go look at ImageNet, for example, you look at the charts of the improvement in ImageNet. ImageNet is run with a fixed number of observations. So all the improvements we've seen over the last 6 years have been in the algorithms and the hardware. None of them been of increasing data because they controlled the amount of data. They were interested in looking at how algorithms performed. And if you go look at other examples, which you can find a lot of, typically you see a nice diminishing marginal returns just right out of the textbook. So data is like any other factor in that respect. I think the way you want to think about progress in this area is not in terms of increasing returns to scale, not in terms of network effects, but in terms of learning by doing. And of course, the more you do, the more you learn, the more effort you put into it, of building a system, studying it, learning from it, the more efficient and more accurate it's going to be. So that's the critical factor that's at work here. On the regulatory side, I think that the example from Google News is a case of a private contract. If you want to exclude somebody from Google News, you put it in your robots text file. It's very easy to do. We even modified the robots.txt file so you can say, I want to include this for certain purposes, like search results. I want to exclude it for other purposes, like Google News. So that's all a contract. It's very efficient and works quite well. If you think about what kind of good you've got with data, you should think about it as non-rival, okay, because the fact that I use some data doesn't impinge on whether you use it or not, and it's partially excludable, okay, partially excludable, because in some cases there might be copyright or legal exclusion. In other cases, it would be contractual exclusion. So you shouldn't think about the data owner, which is much too specific private good-like. You should think about the data controller. So if I acquire some data, I can license it to you. That's a private contract. And there might be standardized terms and standardized things you can ask for, but we could do any kind of contract. And then if you violate that contract, then you go out and private courts deal with the matter. So the important issue is data controller, not data owner, in my view. Finally, the last thing, I think Susan's point was very good, that there's not only the kind of static learning, there's also dynamic learning in the sense of reinforcement learning is what it would be called in the computer sciences, where you're really looking for the causal feedback to say, how can I improve this system in a continuous way? And actually, I think that's huge. That's much, much bigger in terms of its ultimate impact, I think, than simply the machine learning.
Okay, thanks, Hal. And Hal, just a clarification question. When you, in your initial example where you said the ImageNet competition had a fixed number of observations,
Right.
but the algorithms used to compete in ImageNet are trained, and that's your learning by doing example is, in other words, more data means more training, and that has better trained algorithm to compete.
Nobody is disputing free disposal. So if you have more data, it's not going to hurt you, but you generally have diminishing marginal returns, just like any other factor.
Okay. Please, Iain.
Yeah, two remarks on this.
Sorry, Iain, just so some people won't know your background, if you wouldn't mind a couple of sentences, since you've got a different background here than everybody else.
So Iain LeCun, I'm a director of Facebook AI Research, the AI research branch of Facebook, and I'm also a professor at NYU, and I was kind of part of the deep learning revolution together with Jeff Hinton, Yosha Benjo, and a few others. So it's true that the results on ImageNet are due to improvement in architectures, algorithms, hardware. But in the practical deployments and applications of those techniques, the data that are used by Facebook, Google, and others is of course much, much bigger than ImageNet. Right? Both companies can create an ImageNet data set per day, essentially. There's enough people labeling images that can be done. So the impact is different if you have a way of creating data. Another remark on the consequences of reinforcement learning. So reinforcement learning doesn't work in the real world, or doesn't work very well. And it's sort of the same type of learning that happens when you train a pet or a circus animal. You wait for the animal to do the right thing and then sort of reward the animal. It doesn't work very well with computers because the current brand of reinforcement learning that we have is not able to learn sort of predictive models of the world, and therefore has to, if you want to use it to train a self-driving car, the self-driving car will have to crash into a tree about 10,000 times before it figures out it's a bad thing to do. So right now it works only for games. Essentially, it works a little bit also for things for which we can collect lots and lots of feedback, like say ranking for search. So that's a good example for Google or for Facebook. But it doesn't work for training robots, for example. We're missing an essential piece that animals and humans can do. And I think the limit of applicability of AI technology actually is held back, or will be held back, until we find a way to kind of train machines as efficiently as animals and humans can learn.
Okay, thank you, Iain. We've got the last comment from Ben. So we'll take 1, 2, and then we'll move to Chad.
I'm sure we'll be talking a lot more about data and market power and things. I guess on this question of whether there's diminishing returns to data, that seems true in the sense that if it's the same data over and over again, we're talking about observation counts, that's going to go at sort of the square root of n in terms of precision. But what about the scope of data? Like, I would think that one of the big advantages of a very large company, for example, is its capacity to synthesize many different X variables. And if we're thinking about my limited understanding of machine learning, but if you have sort of a larger set of regressors, you can have better predictions. It's not obvious to me that there's diminishing returns in that sense. And an entrant may have a whole lot of trouble sort of being able to get all that data together for capital constraint reasons or other technical reasons that would seem limiting.
Okay, thanks, Ben. And last comment here. Yes, Jim?
So the argument of the paper is that machine learning is a general purpose technology and a method of invention. But prediction technologies aren't new. So machine learning, for instance, is being used to rate credit risk, but we've had computer-based credit assessment since the 1950s. If the argument's right, statistics should also be a general purpose technology, and you should be able to go back and see evidence of the kinds of things you're talking about in the past from previous prediction technologies.